What will happen when a massive supernova star explodes in our galaxy soon? Will we all be destroyed then? The red giant star Betelgeuse is about to experience its final event. As a result of this supercosmic explosion, the star will expand one last time and then be destroyed forever. A powerful shockwave will sweep through space, and the radiation will annihilate everything in the vicinity of the giant. But what consequences can we expect on Earth, and when will this event happen exactly? We will explore this question. Stay with us if you want to stay informed and not miss this important event. Is Betelgeuse our doom? Our sun is big, but Betelgeuse is enormous. The red supergiant is so vast that if you were to place it in our own solar system, it would extend out to the orbit of Jupiter. We've all consciously or unconsciously seen this star. It's one of the brightest stars in the constellation Orion and one of the brightest stars in the entire night sky. If you look very closely, you might even see its reddish color and slight flickering. In terms of color, it resembles Mars, but unlike the red planet, Betelgeuse doesn't wander across the night sky. It remains firmly in its position on Orion's shoulder. What unsuspecting stargazers don't realize is that this star is so massive and luminous because it's dying. Over millions of years, it has swelled into a giant star. Its fuel is running out, and the star will soon meet its end in a brilliant final act. The explosion will last only a fraction of a second. Enormous physical forces will tear the star apart. What will remain is a brightly glowing field of debris, eventually becoming an extraordinarily beautiful cosmic nebula, a neutron star, or a black hole. If we were to combine all the bombs and explosives on Earth, we could never come close to the forces that Betelgeuse will unleash when it explodes in its final event. The explosion wave, swarms of highly charged neutrinos, and fierce radiation will destroy everything within a radius of 50 light-years. We will also feel this event on Earth, and it could happen at any moment. Some experts predict the explosion in 2023. Should we expect serious consequences here, and how can we predict the explosion? Betelgeuse's strange behavior. Experts have been concerned because Betelgeuse has been behaving oddly since 2019. Its brightness rhythmically increases and decreases. This dimming could be a precursor to an explosion. For a long time, it seemed that the giant star was becoming increasingly unstable and a supernova was inevitable. Recent extended observations have shown that the star has regained its former brightness. Betelgeuse likely underwent a massive surface ejection, losing a significant portion of its visible surface. Our sun also regularly ejects parts of its thin outer atmosphere, the corona. However, these coronal mass ejections are tiny compared to the events on Betelgeuse. Betelgeuse ejected 400 billion times more mass than our star typically does during a typical coronal mass ejection. The dimming likely occurred due to a cloud of hot gas. While this explains the light fluctuations, specialists continue to warn that these changes should not be taken lightly. Betelgeuse can still explode at any moment. The last time a supernova star appeared in our Milky Way was in 1604. It's quite possible that there have been other nearby supernovas since then, and we haven't seen them, hidden behind atmospheric gases and dust. It's strange, but we can't see all corners of our galaxy due to its curvature and the clouds of dust that pass through it. Actually, scientists often find it much easier to look into distant foreign galaxies than to observe our own. In 1987, in a neighboring galaxy, the Large Magellanic Cloud, a supernova star named 1987A exploded. Additionally, there have been numerous supernova explosions in other galaxies recently, observed with telescopes. So it has been quite some time since people last witnessed a stellar explosion in our galaxy. Therefore, scientists are eagerly waiting for the opportunity to finally see a massive supernova with their own eyes. Are we safe? When Johannes Kepler became the first modern astronomer to observe a supernova in 1604, the event was visible to the naked eye on Earth. Kepler himself didn't witness the explosion. He noticed the supernova only after a new starburst appeared in the night sky. This event was observed all over the globe on October 9, 1604, and quite a few naturalists of that era left records. The supernova appeared as a very bright spot in the night sky for 2 to 3 weeks and was typically interpreted as a new star or a guest star that had just appeared in our celestial sphere, and then disappeared again. At the moment of the explosion, a supernova reaches a brightness exceeding that of all the stars in the galaxy. For a brief moment, day or night turns bright. Then, in a tiny moment, the flash disappears, and an unusually large and bright glow appears in the sky. Kepler's supernova was most likely a Type 1a explosion, meaning a white dwarf star exploded. Supernovae of this type reach very high luminosities and are visible over long distances. Most likely, Betelgeuse will end its life through a Type 2 explosion, also briefly illuminating the entire galaxy. The remaining disk of gas and debris will be visible for several weeks as a bright, glowing spot in the same place where the star used to be. On Earth, we will feel the distant aftermath of this event, but scientists warn that Betelgeuse is too far away to pose a serious threat to us. The old man is running out of air. Many years ago, Henry Nell, a lecturer at the Hayden Planetarium in New York, studied Betelgeuse and concluded that its final stage had already been reached a long time ago. Nell characterized the star as an old man whose strength is nearly exhausted, gasping for air. In the cores of stars, hydrogen and helium burn, producing energy. The star's energy output sharply increases when a sufficient amount of heavy helium accumulates in its core. As a result, the star expands, becoming a red giant or supergiant. To resist the relentless pressure of gravity, the cores of such stars produce heavy elements, like iron. However, the production of heavy elements also consumes more and more energy. The star's days are numbered as soon as its core starts producing iron, and in the case of Betelgeuse, this state has long been reached. However, the last moments of a star's life, whether 100, 500, or 1,000 years, are nothing more than a sigh. For us humans, these are periods of life, so we cannot know if the people alive today will witness the brilliant end of the star. Betelgeuse is located 640 light-years away from us. This means that light from that place will take 640 years to reach us. Therefore, the dramatic light show and the ejection of massive material we might observe have actually happened 640 years ago. It's possible that Betelgeuse has already exploded, and we will only see it in 10, 50, or even 500 years. If the supernova has already occurred, a large amount of debris and radiation has been ejected into space. These deadly relics of the star also spread out vigorously, but nothing travels as fast as light. As for the debris and the most harmful radiation, we shouldn't worry. They are unlikely to reach us on Earth because Betelgeuse is too far away. However, we can measure neutrino fluxes on Earth. It will take centuries for them to reach us, and by that time, they will have lost much of their deadly charge. The gamma-ray and X-ray radiation wave causes significant destruction only in the immediate vicinity of Betelgeuse. On Earth, we are safe from these effects. Scientists emphasize that we should understand that supernova not only eject dangerous elements and radiation into space, all the elements that compose the star are ejected into space in a fine dispersed form. Elements like iron, gold, and gases are dispersed in space, and these substances slowly and over eons spread throughout the galaxy. Other celestial bodies and star-forming regions absorb such raw materials and use them to form new stars and planets. Are there supernovae near us that can harm us? The danger of supernova should never be underestimated. However, scientists are optimistic. There are unlikely to be stars large enough to explode as supernova in our immediate vicinity. Smaller stars usually do not evolve into supernova, they collapse and eventually become dark, lifeless celestial bodies. Single star systems that are 159 light-years away from us might eventually pose a threat to Earth. This binary system is almost certain to end as a massive Type I supernova. In this system, one star pulls matter from the other until the partner turns into a white dwarf. Due to the huge gravitational interaction between the two stars, this white dwarf will not burn out quietly but will go out in a spectacular Type I supernova. If this happens at a distance of 159 light-years from us, people and all living beings on Earth may feel the consequences. A massive flow of high-energy neutrinos would increasingly affect organic life in our star system. After the star's explosion, it would gradually become brighter for nearly 3 weeks, casting shadows even during the day. The ultraviolet and gamma-ray radiation from the overheated gas layer of the supernova would be deadly for organic life. The ozone layer would be destroyed by these rays, leading to the formation of nitrogen oxide smog. The toxic mixture of X-ray, gamma-ray, and ultraviolet radiation would permanently alter our home. People could potentially survive such a phase only deep underground. Presumably, life on Earth would eventually recover but in a completely altered form. Specialists consider it highly likely that the mass extinction at the end of the Devonian period, about 360 million years ago, was caused by a supernova explosion in our cosmic vicinity. When the binary system will perform this final dance is currently unknown. It could take many millions of years, and whether we, humans, will exist then is a debatable question. Do you feel completely safe when looking at such processes in space, or do these images give you goosebumps?